My friend, when we configure VXLANs with NSX, we really focus in on the switches, the logical switches that provide that functionality. But those switches are only the beginning. We want to be able to connect those switches to each other and to the rest of the network by creating routers. And the first type of router we're going to create is an NSX distributed logical router. So for this hands-on lab, we're in the VMware hands-on lab environment. We fired up HOL 1903, the Getting Started lab. We've launched the Chrome browser, and we're logging on as administrator vsphere.local with the default lab password of VMware1 ! And logging in. Let me show you what our plan is for this particular exercise. Over on the left-hand side, we're going to expand out region A01, and I just want to focus our attention on two virtual machines, app01A corp local and db01A corp local. If we take a look at the VM hardware, we can see app1 is connected to a logical switch called app tier logical switch, and db01 is connected to the db tier logical switch. What we want to do in this lab is connect them to each other using a DLR. Distributed logical router, a router that's going to run in the mind of each of our ESXi hosts. But let me show you what these guys are connected to right now. Up in the top, we'll click the Home button to head down to Networking and Security, NSX Central. On the left-hand side, let's click Logical Switches. And I'd like for us to double-click on App Tier Logical Switch, which will dive in and focus just on that one object. And on the left-hand side, we can see that it is associated with one NSX edge device, the one called Perimeter Gateway. Click back, and let's take a look at DB Tier Logical Switch. And let's take a look at the NSX Edge. All right, it's also associated with this Perimeter Gateway. So what is that Perimeter Gateway? Let's click back once again, and let's select NSX Edges. In the list of existing NSX edges, we can see that there are two types of edge devices already created. One is a DLR, we're going to delete that, and the other one that is currently being used is actually the Perimeter Gateway NSX Edge. Because this is an edge device, that means it supports all sorts of services, load balancing and NAT and DHCP and VPN services, perimeter firewall support. As a logical router, we have a device that can support two things, routing and layer 2 bridging. So if our switches are both connected to each other currently with a router that just happens to be an edge router, why rock the boat? Why change this? Why modify this and go for a logical router, a DLR approach? If those virtual machines happen to both be running on a host, we'll call it ESXi1, but they need to talk to each other, the process of communication is going to require that the packet be forwarded to whatever ESXi host that happens to hold the virtual machine that is the NSX Edge Perimeter Gateway. That means we're going to be performing some dreaded tromboning or hairpinning in order to go all the way out and all the way back. Whereas if we had that router running in the mind of ESXi, then to communicate from one network to another would just involve routing right within the brains of the host that we're connected to. And that's the kind of east-west efficiency that we'd love to see for our virtual machines that are co-hosted on the same platform. And even if the database was connected over here to ESXi2, the process of routing does not have to involve this centralized VM. A could communicate with its logical switch, forwarding it to its own internal logical router, which then can put things on the network and package it and VXLAN it and get it over to ESXi2, who then can receive it and work its way through the logical switch to get to the database. And then when the database wants to respond back, that goes through the logical switch, gets processed by the local router, and then gets forwarded to the VTEP of ESXi1, who can then communicate back to A. So we avoid the middleman of a centralized VM, and that makes things more efficient. First, we're going to do a little cleanup. Let's select the distributed logical router that already exists for the lab environment and delete it with a little red X and say yes. Then we'll need to edit this edge router so that it's not providing the connectivity between apps and databases. So let's double click the NSX Edge. Then we'll click the Manage tab. Make sure we're looking at Settings and then Interfaces. Interfaces are how routers can essentially have default routing. What can a router route automatically? Whatever it's connected to. And under VNIC 3 and 4, we see its connections to the app tier and database tier. We're going to yank those out. So select app tier and then click the red X to delete that interface configuration. And then the same thing for the database. So we're not removing the interfaces, but we're removing the configuration that's associated with the interfaces of this edge device. So now let's get back to ground zero and start building things ourselves. Let's head to Home, to Networking and Security, just to kind of give ourselves a reset. On the left-hand side, we'll click NSX Edges, and let's build a new distributed logical router. We'll click the green plus, that's the new button, or add, and then it gives us a wizard. You can't go wrong. New NSX Edge. what would you like to have as a type? An edge services gateway, something full of services like firewalls and VPNs and NATs and load balancing, or something that is distributed, a logical router that's all about being hosted on each and every ESXi host within the transport zone. We want the logical router right now, so we'll choose that lower option, and we will name it lab_router. We can set up its DNS name, so let's call that lab router, no space, no underscore, so it's DNS compliant. No description needed. We can specify a tenant, which is especially useful in CLI and cloud configuration API support. We can just say tenant 1 for now. It's kind of a context. And then we get to some additional questions. Would we like to deploy an edge appliance? Now, if your head just exploded, just grab a Band-Aid, slap it on, it's going to be okay, all right? I know we just said that what we're doing is deploying a router that's going to exist in the mind of each one of our ESXi hosts instead of setting up a virtual machine, a dedicated appliance, and routing through that. And yet now it's asking us, so did you want to deploy an appliance even though you didn't choose the appliance-based option up at the top? This is the appliance that is there to provide control support, centralized control of firewall and dynamic routing. So this is a centralized brain where the firewall configuration and dynamic routing communication can occur, and then information can be distributed to all of the distributed logical router elements in each and every ESXi host. We're going to allow that to be created for configuration down the road. For now, we're not going to add high availability. We'll look at that at a later time and what that's all about. It's different than the standard ESXi high availability. So we'll leave it with the defaults and click Next. We'll need to specify credentials so that we can log in. The default is admin, and we'll use the lab password of VMware1 exclamation point, VMware1 exclamation point, and repeat for the confirm password. Let's add support for secure shell access, so we could PuTTY into this, for example. We don't need FIPS mode, and we don't need to reduce or add to the syslog level. Info is good. We're not trying to debug for VMware customer support right now, so we'll just leave it with the defaults there and click Next. Then there's this virtual machine we're going to be deploying. So the question is, where will that object go? You'll notice that I could click Next, and if I want to, I could configure this later. Let's go ahead and build it so it's available for future labs if we'd like it. We'll click the green plus, and in the drop-down menu for the cluster resource pool, we'll choose Management. For the data store, we'll choose the iSCSI data store, and then we can skip the rest and allow it to default select those objects. We'll click OK, and then click Next. The HA interface configuration is all about supporting communication between the NSX manager and the router control VM that is used to support our DLR experience. We need an interface, and it's not a routing interface, but it's simply an interface that's going to have the ability to access the NSX manager. So we'll select from the select listing there. Let's click on the distributed virtual port group list. And so on whatever host this virtual machine is connected to, we expect it to be able to find the NSX manager by connecting to the ESXi region A01 VDS management interface. So we'll select that and click OK. We can add an IP address, but you'll notice it's not required, and that's because the NSX manager is going to use a VMware Virtual Machine Communication Interface, or VMCI, which doesn't actually require IP. It's a lower level protocol. We do, at the bottom though, need to configure the interfaces of this edge with appropriate IP addresses. So when we click the plus here, now we're talking about routing interfaces. How will this router route? What's it plugged into? So the first thing we want to plug it into is the app tier. So let's type in app_tier, and that's an internal link that's going to provide connectivity to the app switch. It's there to support that type of east-west communication. Let's click the select button and actually select the app tier logical switch from the list of logical switches. Then click OK. Then we need to configure an IP address. Let's click the green plus, and in order for this guy to be essentially the default gateway of that app tier subnet, it needs to have an IP address of 172.16.20.1. Then we'll click in the subnet prefix length and give it a prefix of 24. Down at the bottom, we leave the MTU alone. And if that makes you a little nervous because you're thinking, wait, I could have sworn Jacob said MTUs needed to be 1600. Yes, when we're talking about the transport network that needs to have all that extra VXLAN packaging supported, but this is an internal interface. It doesn't need to support any of that extra bulky VXLAN content. Let's click OK for now. And let's click the green plus to add the database tier. So we'll type in DB_tier, choose another internal as the type, and click connected to, select, and choose the DB tier logical network. Then click OK. Click the green plus to add to the subnet, and put in the IP address of 172.16.30.1 with a subnet prefix length of 24 and click OK. But what about getting out of here? Do we have any way to route anywhere just other than between the app tier and the database tier? For that, let's click the green plus again and give it another interface. For name, let's type in exit interface. And this is going to be an uplink. This is north-south communication that we're talking about. And for connected to, we'll click select. And from the list, we're going to choose Transit Network 01. This is actually a logical switch that our edge router is plugged into, so this will provide connectivity between the edge router and the DLR. Let's click the green plus to give it an IP address. Click in the blank and type in 192.168.5.2. Then we'll click in the subnet prefix length and type in 24 and click OK. Then we'll click Next. Because we have an uplink interface, we can configure a default gateway. What is the router's way to route if it hasn't been given any other specific instructions? From the drop-down list of VNICs, we can only choose uplink interfaces, but we will need to give it the IP address of the next hop router, which in this case will be 192.168.5.1. So we'll type that in and click Next. It's ready to complete, so let's click Finish. Chugging away, installing and busy. Excellent, we can now see that the lab router is deployed with its 3 interfaces. Let's double click lab_router, take a quick look at it. And on the left hand side under interfaces, we can come here if we misconfigured the IP address, for example, or needed to add an additional interface to this router. Notice while looking at the router, we can see what it's connected to in terms of logical switches. And we saw earlier that when we select a switch, we can see what routers it's connected to. Let's validate that our router is routing for us correctly. Let's click the Home tab and go to Hosts and Clusters. And I'm going to exit full screen mode here. Make sure App01 is selected on the Summary tab, and let's click the thumbnail to get into an interactive interface. We'll click in the middle of the page and log in as root with VMware1 ! As the password. Let's type in an ifconfig, just validate our IP address. Yep, 172.16.20.11. So let's ping our default gateway that we just created on that distributed logical router, 172.16.20.1. And we have success. Control-C to break that ping. Let's go ahead and try and now use that router by pinging the far side and pinging that database server, which is at 172.16.30.11. This will be a test of routing. And we have success. The router is routing. Control-C to break. All right, solid successes. Our router can in fact route. But can I reach anything beyond this particular router? Let's try pinging the next router beyond my DLR. Ping 192.168.5.1. And this is not succeeding. We are failing big time, my friend. And do you know why that's happening? We do a Control-C, up arrow, and we just change that to a 5.2. I do have a functioning interface on the DLR that connects up to that next router. We're not using network address translation, and we're not using dynamic routing. And although the DLR is set to forward all unknown frames to the edge device, when the edge device tries to respond back to the source of that message, such as the app server at 172.16.20.11, the question becomes, does this edge VM have any awareness of this network? The edge network has never heard of the subnet 172.16.20.0. It has no way to route to it, and so the ping message works its way all the way up to the edge device, and the edge device must drop it at the point of trying to respond back to that ping. So what solutions are available? Dynamic routing or network address translation are probably the two biggest, most obvious answers to deal with this issue. Either use NAT to hide this network, make everything look like it came from the 192.168.5.x network, or apply dynamic routing so that we can inform this edge router about these subnets that it has no native awareness of on its own. And so we're going to need to add a new dynamic routing protocol right here between the edge and the DLR if that's going to be our goal. We'll focus on that in a different nugget. For now, I'd like to say congratulations. We just created one of the coolest things in software-defined networking, a distributed logical router, and successfully used it to route between our different subnets and supported its connection to uplink to the rest of the network. This is a critical first step and paramount to getting some of the best performance possible out of our routing environment. I hope this has been informative for you, and I'd like to thank you for viewing.